Hi guys, my name is Brett Reed. I'm here to share a little bit with you guys on how to name branch chain alkanes. Bear in mind this is kind of ground zero of IUPAC naming, and so let's dive right into it. First things first, you got to locate the parent chain. What I've done here is I've pre-prepared a couple notes, and what I want you guys to do is just, if you need to, stop the video, take a peek at the notes, and hopefully we'll get through this. So step one, identify the parent chain. That's incredibly simple. All you need to do is you count the number of carbons, like I've done so here, and whatever chain is the longest, that's your parent chain. In our case, our longest chain here, 7 carbons long, we're going to have heptane. Remember that the suffix to your parent chain with alkanes is going to be an ane because we have a fully saturated hydrocarbon. In the event that we had an alkene, we're going to have something different. We're going to have a non-fully saturated hydrocarbon. The suffix is going to be ene instead of ane to signify that we have a pi bond present in the parent chain. Step 2. You need to look for the nearest substituent on the parent chain. So what is a substituent? Well, a substituent is any of those branches that we numbered originally that's coming off the parent chain. Here's the same parent chain we looked at earlier with step 2. If you notice, I've circled the 2 substituents and numbered them. And the way I've numbered them is based off of which one is closest to the end. Here we have one at the 2 position, and here we will have one at the 5 position. 2 position is closer than 5, and if it were going the other way, this would be 3, and this would be 5. And so we're going to go 2, 5 instead of 3, 5. Simple enough. Next step is to label the location of our substituent groups. Now that we've identified them, like I said, we want to go with which one's closest to the end. That's what we've done here. And now we can name them. Each substituent is designated its own name, same way that the parent chain is. Here, 2, we have an ethyl. 1, 2, ethyl, simple enough. Here at 3, we have a methyl group, only 1 carbon. And so we go in and we name that. The trick here, and you really want to keep this in mind, because on your exams, professors love to flip this at you. They might do something like, here it's lucky, it's 2, 5, and it's in alphabetical order, like I've underlined here and here. What you have to keep in mind is, say that this was a methyl, and this was an ethyl. The ethyl will come first, regardless of it being later in the parent chain or not. It goes alphabetically. So this could be 5 ethyl, 2 methyl. You see what I'm saying? Like I said, it's pretty simple. You just have to remember the alphabet. And again, that's why I've underlined it here. Now we're getting to the end of this process, and again, this is just alkanes. There's no functional groups. There's no cyclic compounds or anything like that. But to wrap up this portion of it, we're going to look at some of the exceptions, and they're not necessarily exceptions as they are just kind of, they break the rules a little bit. They make it a little bit more complicated. And so what we've done here is, if you notice with this carbon, we have 2 substituents on the same chain. And so the step says that in the event that this is the case, you need to make sure to label both. So here, the name is 3-ethyl, remember the alphabet, 3-methyl hexane. Here's your parent chain. They're both on the same substituent, but again, they're 2 different carbons because they have 2 different numbers of carbons. We have 2 and 1, methyl, ethyl, you name it that way. Another exception to the rule is, what if we have 3 identical substituents? In the event that this happens, you're going to go 2, 3, 4 methyl. Here we have 3 methyls, and again, pretty straightforward. You just have to make sure you catch things like this, because professors do like to throw tricks on exams. And also, you need to mention that this is going to be 2, 3, 4, and since we have 3 of these, this is tri. Like, it's simple enough. Di, tri. However many you go in, you use the prefix to indicate that there are 3 of the same on those locations. Okay, last 2 exceptions to the rule. If a parent chain has an equal number of carbons, you need to select the one with the most substituents. Here we have 1, 2, 3, 4 substituents and 7 carbons. We have the same number of carbons this way, but 1, 2, only 2. So we know that we need to name it this way, and we know following the substituent where we need to start here. I haven't numbered it that way because all I was trying to show was to indicate, that they were the same length and so forth. The last exception to the rule here is if you have, in the event that you have two equal substituents from the end, and you're going, okay, well, how on earth am I supposed to select which one to start with? Which one's my parent chain? How do I number this so I can properly name my substituents? What you need to do is look for the first point of difference. If you look here, we have 2, and this would be at 2, and I've numbered both chains both ways. This one has a substituent going this way at the 3 position. This one you wouldn't get one until the 4 position. So you're looking at what would be the difference between 2, 3, 5 and 2, 4, 5. And again, now you need to make sure to select the one that has the first point of difference at the earliest substituent numbering. And that's the end of naming branched alkanes. If you have any questions or comments, please comment below, and good luck, chemists.